Hi kiddos. Today we're going to do optimization, kind of, because we've kind of already done it. So today is actually more about how to use your calculator for some of this stuff. You will not have your calculator on your test next week, but the stuff for which you need your calculator is coming pretty quickly. So now's the time to make sure you have one and you know how to do some of these basic things we're going to do. So I'm going to teach you basic things while we talk calculus. Please make sure you have your 89 and 84 won't cut it. If you have an Inspire, that's great. Good luck to you. I wish you the best. It'll work. Please don't ask me how. You've got to Google that on your own. If you do not have a TI 89, we need to have a discussion because you can rent one. I will get you one, but you got to tell me you need one. All right, so let's look here. We've got these two functions. F is e to the x, g is natural log, and then we have this other function, h, which is f minus g. That's not super intimidating. So h of x is just e to the x minus natural log. Now the question says to find the absolute min on that closed interval and also the absolute max on that closed interval, and then show the analysis that leads to your answer. So this is called optimization because you are optimizing a function. Optimizing means making it as big as or as small as possible. So you're finding absolute maxes and mins. That's what I mean when I say we've already done this. So we're going to go find the absolute max and min of that function. All right, remembering what we did earlier this week, to find a max or min, we first need to go find critical points. So we need to go find h prime, which we can do. It's not a difficult derivative. E to the x is e to the x. Natural log is 1 over. And then we have to take that derivative and set it equal to 0. And here's where I now no longer want to use my brain. I want to use this really nice machine that I have over here. So let's see. I'm gonna pretend like I don't know what I'm doing so much in this question. And everything I'm going to do inside of y equals. I want to teach you how powerful y equals is. So I'm going to put e to the x inside y1, and then I'm going to put natural log of x inside of y2. And then in y3, I'm going to put h of x, which is e to the x minus natural log. I'm not going to type them again. I'm going to use what I've already written so I don't have to type extra. So this is y1 of x minus y2 of x. And notice that I'm really using these 1s and 2s. So it's literally y1 minus y2. So that is there. Yes, I know I have a calculator. So theoretically, I could go to my graph. So I can turn off, if you uncheck them, F4 up here unchecks. So I can uncheck that one. I can uncheck that one. I can go to my window, which is up here. So I have to green diamond window. And if I set my window from 1/2 to 1, which is the interval that they gave me in the prompt, and if I graph that, it's going to take a minute because it's thinking about what y1 is, and then it's thinking about what y2 is, and then it'll graph it together. So if I put these two things together, I could theoretically find the absolute max and min from my graphing screen. They didn't show up, which means my window's not good enough, so I probably need to change my scale. I have a pretty tiny y scale, so let me make that a little bit bigger, see if that helps the cause. And I mean, I could sit here and play with this. If this was, I mean, this is an AP question. I pulled this straight off of an AP test. Here we go. But if I had other things going on, I probably don't want to sit here and play with my window so I can find the absolute max and min, because it's a very steady function here. So it would take a lot of back and forth to make sure I got it exactly right. And I don't want to do that. The other thing I can't do is I can't say the max is at 7 because the graph said so when there's no graph in my answer. They want you to show the analysis that leads to your answers. They want to see you taking derivatives and setting equal to 0. So we're going to go take a derivative. So let's first take the derivative. We're going to go to catalog where everything lives. This is going to be your second favorite button. Catalog, differentiate. You have to scroll. You might have to press this button here to get to letter D and then scroll until you find it, but I'm right there. So I'm going to differentiate. Remember that I put it in y3, so I'm going to differentiate y3 of x with respect to, so comma, x, and then press enter. And that throws the derivative at me. I mean, we already knew because we're super smart, but just in case. So now I need to set that equal to 0 and solve. So I'm going to go back to catalog. This time I'm going to go press letter S, which is under 3, number 3. Scroll for a while because look at all the fun things my calculator can do. And I'm going to go solve. Look at once an equation, comma, variable. Well, the equation I'm going to solve is go up and grab it. If I cursor up, I can grab it. I want it to equal 0. And then I'm going to put a comma x to tell it I want it to solve for x. And I'll press enter. And it's busy. And it says more solutions may exist, which is super comforting. But we're just going to let it sit and be busy for a minute and wait patiently. So patient. There it is, 0.567. So when you take the AP test and you're in your calculator section, you don't have to write, I typed this in my calculator. My calculator said, you just go straight to x equals 0. And I'm going to put a lot of decimals because that's not my final answer. I'm going to use that number later. So I would just want to put a lot of values so I don't have rounding error. Okay, if you remember from earlier this week, this is one of our candidates for a max or a min. I'm not going to bother with a second derivative test because I only have one value and I'm looking for a max and a min. So knowing if that's a relative max or min doesn't help me at all. But now I'm going to take all of my candidates and I'm going to put them into H. And my candidates are my endpoints, my critical points, which is this 5, 6, 7, 1, 4, 3, and my other endpoint, which is 1. Okay, here's another place where our calculator is going to be really, really nice and going to keep us from working too hard. So I'm going to clear this out. Remember that you have h of x in y3. So on my home screen, I want to go call y3, and I want to evaluate it at 0.5. So it's just function notation like you've always done. Oh, it's 2.34187. And then I'll do it again with that 5, 6, 7, 1, 4, 3 value. Got that. Oh, good thing I kept a lot of decimals because look how close these are. That would make me nervous if I had rounded too early. And then I need 1, and that's E, which I know is 2.7. If you don't know that that's 2.7, you can always green diamond, enter, and that gives you an approximation value. So those are my 3 outputs, and then I would just have to go tell all the nice people at College Board that I know that this is the smallest of the 3 and this is the biggest of the 3, which makes absolute min and absolute max. All right, friends, that's all I want to do because I want you to start getting a calculator if you don't have one, and I want you to start using all of these functions in y equals that you've probably never played with before. All right, let me know if you need anything.